Today, I'm going to be showing you how to switch the orientation of pieces, or like twist them or flip them in the edges case. So first I'm going to start with an example. And the cube right now, it's 100% solved except for a couple things. But I'm going to tell you every piece is placed correctly. Then what could be wrong? Well, some of the pieces are twisted incorrectly. And those pieces are these two corners and then these two edges. And as you can see, these edges, they're in the right position since this needs a blue and red edge in between these centers. It's in the right position, same here, also same here and here. They're just twisted wrong. And edges actually have only two ways they can be twisted. This edge could be twisted solved, where this sides would match, or it could be twisted like this, where they don't match. Same here. And then corners actually have three orientations. They can be twisted like this, wrong, twisted another wrong way, and then twisted the right way. Same with this one. So how can we untwist these pieces? Well, I'm going to start with the corners. Okay, so here's an example of where these two pieces need to be twisted. And when an edge needs to be twisted, I'll just call it flipped because it really needs to be just turned on its end. But corner has three possible positions it can be in, so that actually does need to be twisted. And right off the bat, I'm going to tell you that both of these cases are impossible. At least impossible to reach from normal turns. Okay? You can't twist just one corner or flip just one edge. It's just impossible. Now what I did was I pulled the piece out and flipped it myself, but that's irrelevant. But what I'm trying to say here is the only way you can twist or flip pieces is by flipping one piece in its slot and then replacing it with something else and then undoing the moves you did. So let me show you an example of that. Okay, now we're going to learn actually how to twist these pieces. So I'll start with corners because I think they're a bit easier to understand. So basically for corners, since they have three possible positions they can be twisted in, everything needs to be done three times. So how we can twist a corner is it's pretty easy. We just twist it in its place without messing up anything in this top layer. So let's do that. So we bring the corner down, move it away, bring this side up, move the bottom back, bring this side down, move the bottom over, bring this side up, move the bottom back, and as you can see, that's twisted that corner without messing up anything in this layer. Now that's obviously destroyed other things, but all we care about is that this layer is good besides this corner. And we've done that once, but for our rule to actually work, we need to do it 2 more times, and then we'll be back to solved. So let's do it again. This is our second time. Down, move it over, back, move it down, over, up, back. That's our second time, and now when we do it third time, it will bring it back to solved. Since we have a rule that each time, with corners, when we're twisting them, we need to do whatever 3 times, so it goes back to solved. So bring it down, move it over, bring it up, move it back, bring it down, move it over, bring it up, and then move it back. And as you can see, we did that 3 times, and therefore it brought it back to solved. But that's not really useful to us since it just brought it back to solved. So what we can do is, like I said earlier, it's actually impossible to twist just one corner. So, but what if we distribute the times we do that over 2 corners? So maybe we do it once on one corner, but the rule can still apply as long as we do it twice on another. So that will leave us with 2 corners twisted and no corners put back to solved. So let's try that. So we're going to do it once on this first corner. Bring this down, move this over, bring this up, move this back, bring this down, move this over, bring this up, move this back. Okay, so we've done it once now, so that's 1. And now we want to move another corner into this corner slot so we can do it 2 more times. So let's move this one in. And then we want to do it 2 more times, so 1 plus 2 equals 3, so it adds up to 3. So we bring this side down, move the bottom away, bring this side up, move the bottom back, bring this side down, move the bottom away, bring this side up, and move the bottom back. And that's one, but we need to do it one last time to bring it back. So we've stayed true to the rule that every time we're doing something with corners, we need to do it 3 times. So we bring it down, move it over, bring it up, move it back, bring it down, move it over, bring it up, and move it back. Then we need to undo the move that we did to bring this corner in. And we've twisted 2 corners. So this is really useful. So that's really useful because we haven't brought it back to solved. We've distributed the 3 among 2 corners. So that way it hasn't put either back to solved. But what if we want to twist maybe 3 corners? Well, I'll give you a second to think about how we would do that. We can just twist 3 corners by, again, we need to do everything in 3, since it is 3 rotations. So that means we need to distribute it in a way where we do only the move only once for each corner. So say we want to do these corners, we do it once here, once here, once here, then we'll have 3 done. So let's try this. We'll start here, then go this way. So let's rotate this one. Okay, that one's rotated in its place. And now so we've done it once now. Then we put it in this one's place. And then do it a second time. And now we twisted this one, so we've done it twice, and now we need to do it our last time. And then we need to undo the double top turn. And now we've twisted these 3 corners. So as you can see, by distributing the times we do the move, we can affect a multiple number of corners. But what if we want to do 4? Well, we can't really do 4 because, again, it's 3, and there's no way we can add another one onto that because there's only 3 and we can't add another. Now we can take away some by like putting 2 into 1 and then doing a 1 that adds up to 3, but in the end it has to add up to 3, not 4. So how can we do a 4th one? Well, let's do that. We can rotate 4 corners by just doing what I did before, which was rotate 2 and distributing it like do it once on the first one, then twice on the second one, and then do that same thing in the back, and effectively we'll have rotated 2. This is a really easy solution to that problem. And you can do it for just about any number of them. So let's do it. We rotate this one once. That's both rotated once. Then we put it in this one's place. And then rotate this one twice. One more. And now we've twisted these 2. So now we want to flip the cube around and twist these 2 the same way. So we rotate this one once. Put it in this one's spot. Then rotate this one twice. Then undo the U-turn, and boom, we've twisted 4 corners. We haven't moved them at all, we've just twisted them. So now I'm going to talk about how to twist edges. To make this clearer for you, I already rotated the edges so you can actually see them being rotated. So as you can see, we need to rotate both of these. Well, this can be done with a mix of a commutator and the same kind of idea for twisting corners. So since edges have 2 orientations, 2 ways they can be flipped, that means we need to flip it once, and let's see what happens if we flip it again. Okay, that's the best way I can explain it. So let's look at a correct one, and let's flip this one in its place, okay, without affecting anything in its layer. We're just looking at this one. So we flip this one by bringing it down, the edge is down here, moving the bottom away. Edge is here, it's safe here, so we can move this layer back up, then move this back. Now we actually need to twist the edge, so we bring the middle down, then move the bottom twice, then bring the middle up, and we've twisted this edge. Okay, now if we do that one more time, since each edge has two orientations, that will bring it back to solved. So let's do that. Do it one more time. And then bring this middle up, move this over here, bring this down, move this over, bring this up, and we've brought it back. Okay, so we know that if we twist it twice, then it's going to bring back to solved. That's just easy. Now, since that's 2, we can distribute it among 2 edges so it flips both, and it brings the cube back to solved. So let's do that. So let's do it once here. Flip this edge, bring it down, move it over, bring this up, now we bring this back, actually flip it, and now we put this one in its spot, similar to the corners, then we undo the moves, then undo the U-turn, and boom, we've twisted 2, or flipped 2 edges. So it's really quite easy. Next we're going to get into twisting centers, which is a little bit harder to get a grasp on. To explain twisting centers to you, I've drawn an arrow on each of the centers, since there's not really a way of telling the center's orientation without using arrows. So as you can see, both are facing up. And these kind of follow the same property as edges, where if we twist one and then replace it with another and untwist that, that will twist too. So let me explain that. So we see that both of these arrows are facing up, okay? So I want to twist these. There's no real reason you'd want to do this, but it's just kind of interesting. So what we do to twist it is we bring the center up, okay? Then we rotate it, like that. Then we bring the center back down. It's really not too hard. And now we move this center into that center slot, okay? So we move it into that slot, then bring the middle layer up, move the top back, then bring the middle layer down, and then move the middle back. And now you see that they aren't both facing up, they're facing towards each other. So that's really how you rotate centers. And I hope you enjoyed the video. This, if you like this video, you should go watch some of my other videos on like commutators and conjugates, and bye.